Hello class, in this video we are going to review composition within a Taylor series. So, what this means is if we have a function f being represented by a Taylor series, we could replace each x with a different function, in this case g of x is equal to c times x to the kth power, and we could replace each x with that. So this is going to make a sub 0 plus a sub 1 times g of x, plus a sub 2 times g of x squared, plus a sub 3 times g of x cubed, and so on, until the last term, a sub n times g of x to the nth power, and so on. The interval of convergence of this new series may be different than that of the first series, kind of depends on what was being composed for it. So, with that being said, I have here two functions that we would want to find the Taylor series for. So the first one, e to the negative x squared over 2. So it took that e to the x and replace it for this one, right? So for e to the x previously, right, that was 1 plus x plus 1 over 2 factorial times x squared plus 1 over 3 factorial times x cubed, all the way down till we get to 1 over n factorial times x to the nth power, so on. And the interval of convergence from this was negative infinity to infinity. So, replacing each of those x's with the exponent here, right? This exponent being this negative x squared divided by 2, and that's going to replace each and every one of these x's. So what does that look like? Once we replace it, that makes this 1 plus, we would have negative x squared over 2 plus 1 over 2 factorial times negative x squared over 2 squared plus 1 over 3 factorial times negative x squared over 2 cubed. This continues going. The nth term is 1 over n factorial times negative x squared over 2 to the nth power, and that keeps on going on. So this can slightly simplify, right? To make it a little bit less messy looking. This makes 1 minus a half x squared plus 1 over 2 factorial times 2 squared times x to the 4th power minus 1 over 3 factorial times 2 cubed times x to the 6th, and this keeps going on. The nth term is negative 1 to the nth power divided by n factorial times 2 to the nth power times x to the 2n power. And that, again, that keeps going on for that. The second one I have here, 1 over x plus 1 over 1 plus 4x, right? This can be rewritten slightly to be 1 over 1 minus negative 4x. And in a previous video, we saw that the Taylor series for this one, for this part A here, this new Taylor series also converges from the interval of convergence for this one is negative infinity to infinity. For this one, for part B, the basic Taylor series for that we previously saw for this being, let me label it actually for this. This is for 1 over 1 minus x. That being 1 plus x squared plus x cubed, all the way down to x to the nth power. And that one converged from -1 to 1. So, again, we're placing, and let me use a different color to highlight this. We're placing the value of x then with this negative x to the negative 4x with each and every one of these x's in our Taylor polynomial. This is going to make first 1 plus negative 4x plus negative 4x squared plus negative 4x cubed. Again, this keeps adding down until we get to negative 4x to the nth power, and so on. This can be slightly simplified, right, to make it look slightly less messy, to be 1 minus 4x plus 16x squared minus 64x cubed. This keeps on going until we get to the nth term, which is -1 to the nth power times 4 to the nth power times x to the nth power. And this keeps going on after that. So we could also replace this into an interval of convergence, right? So the original one was between -1 and 1 for the value of x for that interval of convergence. This one, for the interval of convergence. So if we replace, again, inside of our interval of convergence, that x with a negative 4x, this makes -1 is less than negative 4x, which is less than 1. So this simplifies nicely to be -1/4 is less than x, which is less than 1/4. When you divide everything by a -4 and slightly simplify, so this interval of convergence is -1/4 to +1/4. Let me know if you have any questions or concerns. Thank you.